So the answer to this question is that it's the X chromosome and it's likely to be recessive. Now, how do we come up with that? Well, we're pretty sure that it can't be the Y chromosome. Think about it. Take this father as an example. This father up here is affected. That means he'd have a Y chromosome with the affected allele. He had 2 daughters. Did he give his Y chromosome to a daughter? No, there's no way, right? Because they're daughters. Daughters are by definition XX. So if this daughter is XX, she didn't get any affected Y from the father. So how did she pass on the trait to her son? Right? That just doesn't make sense. It must be the X. Here the X is affected, and the father passes that X on to this daughter. But because this daughter has another X from the mother that's unaffected, you don't see the trait. She's just a carrier. But when she has a son, the son is XY. The son has to get the X from the mother. She gave him the recessive allele X. Now, we also suspect that this trait, this allele causing this trait, is recessive. Because as we mentioned before in our autosomal inheritance pattern pedigrees, recessive traits tend to skip generations, and unaffected parents have affected offspring. Whereas dominant traits show up in every generation or almost every generation, and many times affected parents have affected offspring. And that's not the case for this pedigree.